drawing along with me, all of you, one simple graph. So we all know AC current is represented with certain graph.
Sir, your board is not clear, sir.
Okay, one second. Okay, now you are able to see the board, whiteboard?
Yeah, sir.
Yeah. So all of you draw along with me. First you draw the x-axis and y-axis. And now, so first in order to derive the RMS current, we must assume certain conditions. So this name of this graph, I'm giving it as the current I. And it is changing with respect to theta or time, or I can also write omega t. So here you can represent it is changing. This graph is changing with respect to angular seconds. Omega means why we are writing here omega, because the current is not flowing in a linear direction. It has got positive of cycle and negative of cycle. So any current which is flowing in different directions, it can be represented by omega. So please mute all of you. And one more thing, if you are unmuting, you see that you are at lonely place. Now, so after drawing this one, we know the current, AC current. We are drawing the AC current. This is one cycle. All of you see that you are having equal amount of positive of cycle and equal amount of negative of cycle while drawing. So you can add any number of cycles here. Okay, I'm just adding 2 cycles. So here everybody know this is a basic thing. So here this will be 0. And what is the off cycle range? If I'm assuming
Pi.
pi. So it is nothing but pi. And here pi means 180. Here it will be 2 pi. Okay. And here it will be 3 pi. Okay. So what is this value, everyone? So this value is nothing but, anyone tell me what is the name? Here it is the peak value, yes or no? So peak value or maximum value is a part of the AC current, which explains what is highest position of the current during positive and during negative. Yesterday we have seen, but today, now one more thing, let me draw this one. Average current. Average current is a part of AC current. So I want to indicate the average current. What is the value we got yesterday for average current? Anyone?
0.
0.637. Okay. Average
0.637.
Average value for pure sine wave is 0. Okay. But we have derived for only off cycle. So we have to remember this derivation. So average current, show the average current means average current. Here we are representing I average. Here only you write as I am writing. I, you write here AVG, I average equal to, what is the value? 0.637. You write here, please, all of you. Okay, you can write here 0.637 into IM. So how to indicate this one? Average value is a part of the AC current. So here it comes here. Thus area is nothing but this one. And here you represent I average. So this is A, B and G. Okay. Sir, why you are drawing this here horizontal line? See, if you are at different place, please mute yourself. Okay. Sir, why you are drawing here I average means I average is a part of the AC current. Okay. So its value is how much? 0.637 into IM. So now all of you, one simple example I am taking. So 0 to pi and pi to 2 pi, 2 pi to 3 pi, which is a common value? That is 2 pi minus pi is how much? Pi only. And 3 pi minus 2 pi is how much? Pi. And pi minus 0 is what? Pi. So the common value will be pi. Okay. Similarly, now you tell, I'm taking a rough graph. Okay. So if I'm saying this is the graph here, it is continuing. And I'm writing here T, capital T. Let us say instead of pi, I'm writing T. And here it is nothing but 2T. So tell me the common value. T minus 0 is T and 2T minus
T.
2T minus T is nothing but T.
3.
2T minus. So depending upon the graph, you will get the common value. Okay. So all of you have drawn this graph now. Okay. We'll come back to this particular graph. Now let us go for the definition of the RMS current. Okay. So which is from second unit, this derivation and this question you are going to get compulsory. So now all of you. So RMS value means RMS current is what we are supposed to represent. Examination, if they ask define RMS voltage, same answer. In the place of current we have to write the word voltage. Okay, when I am explaining for current or voltage, the explanation remains same. So first, what is RMS current in simple words? Okay, so I am confident that even if you study any textbook or in the internet also you can search RMS current, this explanation will be simple and perfect what you are studying. Okay, now RMS current is a part of AC current. First, for common man understanding, sir, what is RMS current? It is a part of AC current, but which performs, what is the word we have written here? Anyone student?
Real work.
Real work. So in simple line, we have to give the explanation. We have studied peak current, peak to peak current, instantaneous current, average current. What is the use of all these currents? All these currents are doing the real work? No. What do you mean by the word real work? Real work means if I am passing the AC current, the bulb is on or not. If the bulb is on, then we say that current is doing the real work. So RMS current is a part of AC current which performs the real work means last line I have written here. Now one student read what we have written here.
Bulb motor.
Bulb motor.
Bulb turned on only because of RMS current if AC current is flowing through them. Yes. Now remember all of you, AC current means we got positive off and negative off. That current whenever it is flowing through the bulb, RMS current which is a part of AC current, that current is only responsible to turn on the bulb. Understood all of you? So now what is this second? One more line. RMS current which is a part of AC current is responsible to create which energy? Anyone tell me what we have written?
Heat energy.
Heat energy and magnetic energy.
And magnetic energy.
Yes. So we are saying that whenever current flows through the wire, magnetic energy is created. But which current is creating the magnetic energy? RMS current. In simple words, the current which we are getting in our house is of course AC current, but RMS current, which is a part of that AC current, is doing is doing the real work. Okay. So now, first basic definition. Here, any question is there? Ask the question. D. Kalyani, please mute yourself. Okay, any question is there, you can ask. So now, so slowly we are going to discuss. So what is the real name of the, what is the name of the RMS current? No, you come back to this one. RMS current, what is the full form here? We have written root of the mean of the square of the
Sir, your voice is breaking, sir.
One second, give me 1 second time. Just 1 second, I'll just modify this one. Okay, now it's okay, the voice, all of you?
Yeah. Okay, sir.
Right. So this definition is very important, slowly we'll take. RMS current, RMS full form is what? Root of the mean. Mean means average of the square of the current. So this full form we are writing only for mathematical equation. But what is this RMS current? RMS current is another name is what? Anyone read out here? RMS current is the true current, or real current. RMS current is the true current. In the question, they will also ask you define true current. True current means RMS current. So why the name RMS means only?
What is real current and what is true current?
Both are same. See why I am using the word real or true means because if you are having a bulb, if I am passing the AC current, which has got the combination of peak current, peak to peak current and RMS current, which is a part of AC current, it will turn on the bulb. Therefore, this is called the real. So, real current or true current, both are same only. They are doing the real work or true work. Therefore, they have given two names, true current or the real current. Is it fine? Okay. You can use real value. You can use the word real or true. So RMS current is a true current or real current which performs the real work. What do you mean by the word real work? Means to turn on any bulb, to turn on the tube light, to turn on any fan or the motor. So RMS current produces, now this is important. So how can I confirm that my current is doing the real work? So first indication is nothing but that current should create dash energy. You see what is the word I have written here?
Heat energy.
Heat energy.
Heat energy.
So you are saying, sir, I am generating the current. Okay, what is the proof that the current is doing the real work? Means first, when that current flows through the wire gets heated up. If heat energy is not created, we cannot confirm that the electricity is generated. Okay, so now what is the next explanation of RMS current means? So here this line I will explain. RMS current produces the same amount of heat and performs same amount of work done by which current here? DC current. DC current. So RMS current is equivalent to DC current. It is not equal. So RMS current behavior performance is equivalent to DC current. So whatever the job done by the DC current, it will be done by RMS current. So what is the definition of RMS current means in practice? RMS current, what is the first one statement? All of you, first line is what? RMS current is a part of AC current which performs the real work. Okay. Okay. How much, what is its part? Whether it is 50% or 80%, we'll see with the derivation. RMS current is a part of AC current which performs the real work. Okay. RMS current, which is a part of AC current, is responsible to create heat energy and magnetic energy. So the current which creates heat and magnetic energy, if for the AC, is nothing but the RMS current. So what is the next line? Bulb, motor are turned on only because of RMS current if AC current is flowing through them. I am speaking the AC current, not DC. Second unit is entirely AC only. So RMS current is equivalent to DC current because whatever the job done by the DC current, it will be done by RMS current. RMS current is a true current or real current which performs real work. It produces the same amount of heat which is done by the DC current. So now we'll see with everything we have to explain with one simple diagram. All of you examination also this diagram you must draw. So first assume how to explain practically RMS current. So I am taking one battery. You can see a second figure. Battery means 10 volts. Okay. And what is this symbol? Anyone tell me? Circle, and it is having positive and negative of cycle. This is called AC, but this is called the switchboard. All of you in your house, you have got the switchboard, no switch plug. That plug circuit is this one only. If I turn on that switch, I am having the positive and negative of cycle. Okay. Now this is AC voltage, and this is.
Your voice is not clear, sir.
Okay, 1 second. Okay, you see, just follow. Everyone, 2-3 students, you confirm the voice regarding the voice. Is it okay now?
Yes, sir.
Okay.
Sir.
Okay, 1 second. Just change the settings once. Okay, it is full. The volume is also full. Right. Now you see, this is AC voltage, that's first circuit, and here it is nothing but the DC voltage. So when a DC voltage is turned on, how much current is flowing through the wire? Anyone see and tell me? They have given 5 amperes.
5 amperes.
5 amperes.
5
Okay.
amperes.
Now AC voltage is also turned on, and how much current is flowing here again?
5
amperes.
RMS.
And clearly they have mentioned 5 amperes. They have given. They have not mentioned 5 amperes AC. They have mentioned 5 amperes RMS. RMS. That is when AC voltage is turned on, only. Kalyani, please mute. You are speaking with other people and you are unmuting. Please mute. right? So here in the circuit, why they have not given AC current? Because when voltage is on, which current will flow through the wire? Peak current? No. Peak to peak current? No. Instantaneous current? No. Average current? No. So which current can flow through the wire? RMS current. That's why they have mentioned here clearly. RMS current only can flow through the wire, and when it flows through the wire, what's going to happen? Power dissipated. Power dissipated means the real name is heat energy is created. How much amount of power is created? 50 watts. And when the DC current is also flowing 50 watts, so we say RMS current will perform same amount of work which is done by the DC current. So what is the power formula? Anyone? I square into R. Power formula, we got two formulas. All of you do. Current is how much here? 5. 5 square into 2. You do, all of you. 5 square is 25. 25 into 2 is how much? 50. So, yes, power dissipated means power consumed. In your house, if somebody asking how much power is consumed by your smartphone, means we should say P is equal to I square into resistance of the phone. I square into R. How much power is consumed by the bulb? P is equal to I square into R. So we say here I square 5 square into 2 is nothing but 50 watts. So same amount of power which is consumed by DC current will be done by the RMS current. So you can draw this circuit in the examination explaining the behavior. For you can also take 3 amperes or 2 amperes. It is not compulsory 5 amperes. Only thing we have to show that the current which is flowing through the wire, if AC voltage is on, that current is nothing but RMS current. Now in simple terms, anyone tell me what is RMS current? All of you. First word, RMS current is a part of AC current. Now what is RMS? RMS full form, root of the mean of the square of the current. Sir, why you are writing this one? So only for derivation we use this particular name. But what is the real name of RMS current? RMS current is the true current or real current. RMS current is a part of AC current which performs real work, and RMS current behavior is equivalent to DC current, and RMS current is the only current which creates dash energies. Tell me anyone. RMS current only can create
Heat energy
and
and
magnetic
magnetic energy.
Right. So bulb, motor or any object is on means it is on only because of RMS current. So in your house, which current we are getting? Of course AC current. But when I turn on the switch, which current is flowing through the fan? Which current is flowing through the fridge? RMS current. Understood all of you? Now one question. Can a peak current flow through the wire? Peak current.
No.
No. Peak current, peak to peak current, they are representing only the graphical, that in that graph what is the maximum position and minimum position. So peak current cannot be flow through the current. Now you see derivation, all of you, we are coming to the derivation now, all students. So remember one thing now. So you can ask n number of times for this derivation. This is the toughest one. Okay. So I'll do one thing here, 1 second. So you can take the screenshot or you can have this one, but 1 second, just let me. So in second unit, RMS current derivation is very much important. So I'm just maximizing this one. And please mute everyone. If question is there only, you unmute. And this is the toughest one. So all students on the screen, you are able to see one derivation, right?
Yes, sir.
Okay. So all students, now you see. So we are supposed to derive the expression for RMS current. What is the value of that RMS current? You are saying that RMS current is a part of AC current. So what is the value we require? So first, all of you, AC current, what is the formula for AC current? Yesterday we have taken I is equal to Im sin omega t. I can also write I is equal to Im sin theta. But I have to draw the graph. In that graph, x-axis should be theta. If I am writing here omega t, x-axis should be omega t. If you are writing p, then x-axis should be p. Okay. So I is equal to Im sin omega t. Okay. Now, what is the RMS full form? RMS current full form? You see all of you. Sir, why you are getting T here means, now I will take you back to this particular diagram which we have drawn. All of you on the screen, you are able to see the diagram, right?
Yes, sir.
Okay. So all of you see, I can do my derivation with this one. So let us say, so this is my graph and this is my current. Okay. So if I am writing here T, the common value will be T. Or if I am writing here pi, the common value will be how much? Pi. Okay. You, before doing the derivation, you have to write this, draw this graph. So all of you, let us say T is equal to pi. We can assume, I can assume the T value is equal to how much? T is nothing but pi. If I'm writing, so at last step, I'm going to substitute. Because I'm drawing this graph and pi is a common value, let us assume the time period T is equal to pi. Is it understood, all of you? The time period T is equal to how much for this graph? Anyone?
Pi.
Pi. So pi. So you must, yes, you must draw this graph and here let T is equal to pi. T is the time period, common time period. Now you see, come back to the derivation. So now you see here, okay, what is RMS root, square root? So square root can be written, all of you in brackets I have written. Square root, instead of drawing the square root, I am writing whole power 1 by 2. Is it clear, all of you? Whole power 1 by 2?
Yes, sir.
Okay, square root. Instead of square root, we have written the whole power 1 by 2. Now, root mean. Mean means what? Average. Now, average current, what was the expression? 1 by pi integral 0 to pi. Already I mentioned T is equal to pi. Examination, you can write directly pi or you can write the T here. So what is the average current expression? You see, all of yesterday we have done area of the curve by length of the curve. What was the length yesterday? Pi. It was taken in denominator. And area was what? Area is what? Integration of 0 to pi. I of t dt. Yes, integration of 0 to pi. So area we have taken 1 by pi, integration of 0 to pi. And now what is that value? Current. But here what they are saying, root mean square. So square of the current. I value we have taken square. Understood? Yesterday I have differentiated with theta. Now I am taking with dt. D omega t will take. So no need to worry. D theta also we can take. Now anyone, I am repeating once again. Sir, what is this expression means? First, yesterday we have done the average current. Average current expression is what? 1 by pi integration of 0 to pi I dt. I d theta we got. Okay. I am just modifying that one. In the place of pi, I am writing t. 1 by t integration of 0 to t. Now it is what? Root mean square. Square means here I square dt. I square we are keeping. Is it clear, all of you? I repeat once again. Root. Yes. Okay. Root we have kept 1 by 2. Root. Square we have done. Average means what? Root of the mean. Mean means average. So mean, we are formula for the mean is nothing but average current. 1 by t integration of 0 to t I dt. Okay. So now what is I, all of you? We have taken here I is equal to Im sin omega t. So we have substituted here.
Omega t.
Just without disturbing any value, we are just substituting Im sin omega t, but it is square. So I square m sin square omega t dt. It is having square I square m sin square omega t. Okay. Now I square m means peak current. Im means what? Peak current. It is constant. Let us bring outside of the integral. So now you see in trigonometry you are having submultiples. Sin square theta is equal to 1 minus cos 2 theta by 2. All of you remember the formula. What is the formula for sin square theta? 1 minus cos
1 minus
theta
cos
by 2.
omega theta by 2.
Yes. Therefore, what I am having? I am having instead of theta omega t. So I am not disturbing anything. Sin square theta means 1 minus cos 2 omega t by 2. This is from the trigonometry formula. I am not applying integration. Okay. Now I square m is constant. Bring that one outside the brackets. Yes, we brought. And now what we have done? What we are having? 1 minus cos 2 omega t by 2. Now you see, all of you. Separate this one. 1 by 2. This dt, integration of 1 by 2 dt and integration of minus cos 2 omega t by 2. So integration of 1 is nothing but t, yes or no? T by 2. We are going to get t by 2, 1 by 2 dt is nothing but t by 2. Now any one student, you tell me, what is integration of cos?
Minus sign. Minus sign.
No,
Minus
integration
sign.
of, remember, integration of sine is minus cos and integration of cos is only sine.
Sine.
Integration of cos is only sine. Now integration of cos 2 means what? Cos 2 theta. Integration of cos 2 theta is sine 2 theta by 2. Into 2 derivation will get. All of you, please don't get confused. Derivation of cos 2 theta means cos 2 theta, sine 2 theta into 2 will get. Integration means what? Integration of cos 2 theta means sine 2 theta by 2. So already 2 we are having, okay, and 2 omega we are having. So integration of cos 2 omega t is nothing but sine 2 omega t by 2. Already 2 is there, therefore we get here 4 omega. So I repeat once again, integration of cos 2 omega t is nothing but sine 2 omega t by 2 omega. Already 2 we are having, so it becomes to how much? 4 omega. Is it clear, all of you? Because we are differentiating with respect to dt. So I repeat once again for this one. So what we have done, what is the formula for sine square omega t? 1 minus cos 2 omega t by 2. So bring I square m outside and apply integration separately for 1 by 2 dt and integration of cos 2 omega t by 2 dt. So when I apply integration separately for 1 by 2, it comes to t by 2, okay, minus, already minus is there, integration of cos 2 omega t. Now all of you tell me, what is the integration of cos 2 omega t?
Sine theta by 2.
2 omega t by 2 omega. Sine 2 omega t by 2 omega. Already we are having 2, so it becomes the 4 omega. Is it clear, all of you? So integration of cos is nothing but sine. We got this one. Okay. Now I am applying the limits. Limits are nothing but square root is taken. What are the limits now? All of you, what are the limits? Integration we have taken 0 to t or we can take 0 to pi. So 0 to t we have taken. 0 to t. Now all of you see upper limit t you substitute, you will get capital T here, and 0 by 0 is how much? 0 only. 0 by 2.
0.
Now you see, all of you, I am substituting here t. Now you write in the brackets, all of you don't get confused. Here they have not written. What is t in the very first derivation I mentioned? What is t?
Pi.
T is equal to pi. T is equal to pi. Okay. Yes. Now you substitute here in the place of omega t. That is omega t is nothing but pi. So sine omega t is equal to pi we are going to write. Okay. Omega t is equal to. Now you see. Sine 180 is how much? Anyone student tell me?
Sine
1.
So all of you see here, I am just writing here. Remember this. One second. Yes, 0. Sine 2 omega t is there. We got this expression. Now you see, I'll just write so that there will not be any confusion. So what is the expression we are having? We are having sine. What is the expression we are having? Sine 2 omega t. Yes or no, all of you? Sine 2 omega t. Omega t is equal to capital T, and capital T is equal to how much value we are having? Pi. So what is the expression we are going to get there in the brackets? Sine 2 pi. Understood, all of you? Screen is visible now? New screen. Okay. So we got the expression. We got the expression. Okay. 1 second, all of you. I just modify here also. So this is very little bit confusion will be there, but you have to be perfect. So all students see here. Now this derivation is able to, you are able to see the derivation on the screen?
Yes, sir.
Yes, sir.
Okay, in that one only we got the derivation. Now you see. So what is this one? We got sine 2 omega t. In the place of 2 omega t, I am writing t. But what is t? All of you, t is equal to pi. Therefore, I can write directly sine 2 pi. The next step here I am showing. Sine 2 pi. Sine 2 pi is how much? Sine 180 is 0. Sine 360 is also 0. Sine 2 into pi is how much? Sine 360. So this entire terms becomes 0. So what is this right hand side? Sine 0 is 0. Sine 180 is 0. Sine 360 is 0. So this right hand side becomes entirely 0. And what is the next one we are having? So that's why we got here 0. So no need to write all these things. What is sine? Sine 2 pi, everyone tell me. Sine 2 pi value. 2 into
0.
180. Sine 2 pi, sine 180 is 0. Therefore, this term will become 0. Therefore, we are having this expression I square m by t into, now we are t. You can also substitute here pi if you want. Okay. Now, what is expression? T get cancelled. Yes or no? T and T get cancelled.
Yes.
We are left over with I square m by 2 under the square root. So I am applying the square root now. What's going to happen? Im divided by 2 is under the square root. So Im by root 2. What is the overall expression we are getting? Im by root 2.
Im by 2.
Im by root 2. All of you in your calculator you do 1 by root 2. How much you tell me now? 1 by root 2.
0.707.
0.414.
No, wrong. 1 by root 2. Root 2 is 1.414. That is 1 by 1.414 you do. Root 2 value is 1.414. 1 divided by 1.414.
0.70.
Yes. 7. Now the answer is, all of you, 0.707 into Im. You remember like that. 0.707 into Im. So what is the RMS current formula? RMS current formula is what? 0.
Im by root 2.
Im by root 2 or 0.707. So once again, 0.707. 1 second. Now we are going to complete the graph here. All of you remember the graph which you have drawn. Now all of you will complete that graph. So what is the formula for RMS current? Just now we have done RMS current formula.
0.707 into Im.
Now you tell me which current is greater, average current or RMS current? Average current, what is the value we got? 0.637 into RMS current.
0.637.
Yes.
RMS current is greater.
Now all of you see, I am completing the graph now. We have shown the peak current, we have shown the average current. Now we are showing the RMS current. Where I have to draw this one? Above the average current or below the average current?
Above the average current.
So all of you draw along with me. Draw neatly the RMS current. Okay. So with arrow marks, you can draw here and indicating RMS current. I. What is symbol? You can write like this. I, capital letters, R, M, S, suffix, RMS current, and this is the. So what these arrow marks are explaining, this region is nothing but entirely RMS current, and this region is nothing but average current. So here also we'll indicate here, it is nothing but RMS current. Now you tell me, all of you, yes, into your house, what is the voltage value you are getting? Anybody know? What is the voltage we are getting? AC voltage. Now I am speaking with respect to voltage because voltage is there. Anyone, any idea what is the value of the voltage which we are getting to our house? 230 volts. Remember, all of you. For the industries, we are sending 400 volts. All of you, yesterday you have seen assignment I have given near your poles. How many wires are coming to your house?
Two wires.
Two. All of you have checked that one? All of you have checked really, or you are just telling 2 wires?
Really, we checked.
You checked. Anybody asked question what you are doing actually? Okay. So all of you complete your graph. Okay. Now I am giving one question. I'll see how many of you will do. Finished all of you this graph?
Yes, sir.
Yes,
okay.
sir.
Okay. Now I am giving the question, all of you. Now you see. Calculate RMS voltage if the peak voltage. Calculate RMS voltage if the peak voltage is 3 voltage. I can use the word current or voltage depending upon the problem. 325.25 volts. Calculate.
Sir, once again.
Calculate the RMS voltage. See, when I say RMS voltage, what we have to write? You see on the screen, I am writing VRMS. Okay. Calculate the RMS voltage if the peak voltage or maximum voltage is, you see on the screen, peak voltage how much I have given? 325.25. 325.25. Anyone tell me the formula now? What is the formula for RMS voltage or RMS current? So they have given question voltage or current? Voltage. So VRMS equal to, yes. What is the formula for RMS voltage or no?
I by root
0.707.
707.
0.707 into what they have given VM. So we'll write VM only. Understood, all of you, in brackets. Now you multiply and tell me the answer, how much you are getting.
230 volts, sir.
230 volts. Yes, right. 230 volts. Now all of you just see it. All of you understood the question? Question is simple. Calculate the RMS voltage if the peak voltage is 325.25 volts. So RMS voltage or RMS current? RMS current, what is the formula? IRMS equal to 0.707 into IM. And if the question is given as voltage, we'll write VRMS equal to 0.707 into VM. Understood, all of you? Don't get confused here. What is the answer you are getting, all the students? 230 volts. Okay. Now diagram I have to draw. I have to draw the diagram. All of you draw along with me in the rough column. See, all of you. Draw this one AC voltage. Whether it is AC voltage or AC current, it is nothing but having positive half cycle and negative half cycle. Draw fast in the rough column. So what is the peak voltage given in the problem? What is the maximum or peak voltage? Here, what I have to write? IM I have to write or VM? As per the question. VM. Yes, peak voltage, how much they have given VM?
325.
325. 325.5.
0.25.
0.25. Okay, 0.25. Okay, you can write. Now you tell me. Now all of you listen carefully. When you turn on the switchboard, peak voltage is how much? 325.2. But out of 325.25, only 230 volts is given to the fan or is given to the bulb. Yes or no? The 230 volts is called the RMS voltage. Just now we have proved, no? So what is the voltage we are getting to your house? 230 volts. 230 volts is RMS voltage, which is a part of 325.25. So only 230 volts is doing the real work. So when you turn on the switch, you see, all of you, your cell phone charger input, they will write 230 volts. So for the fridge or wherever the switch is present, today onwards, if somebody asks you, wherever the switch is present, how much voltage will get to your house? It is calculated by the government of India. So 230 volts, and the peak value is 325.25. But out of 325.25, only 230 volts is doing the real work. Understood, all of you? Okay. So remaining values are peak values. So only with one example you will never understand. We'll take the problem in the next class. I request everyone to go through this derivation. Tomorrow, you just write today only in the notes. All of you, number of times you practice. Tomorrow I'll keep test on the RMS current derivation only. I'll do that one with one software. RMS current derivation test will be there on Monday. Okay? All of you. Is it fine?
Yes, sir.
Okay, sir.
Sir, notes for this.
Yes, I'll say RMS average current notes today. I will give you after the class along with this video. Okay?
Sir, yesterday's average also. Average current.
Average current, RMS current material today evening I will give you. Okay? For both EEE and CS students. Right. Okay. Any question is there? And regarding the internships, everything from Monday we'll see that one. No need to worry. Okay?